So here in number 9, we have the limit as x approaches 0 from the right. Well, if I do direct substitution, I get infinity minus infinity, which is an indeterminate form. Now, in order to apply L'Hopital's rule, I need to create a rational function, f of x over g of x. In order to do that, for this function, I need common denominators. So this becomes the limit as x approaches 0 from the right of sine x minus x over x times sine x. So this is my f of x now over my g of x. So I can check both of those limits. The limit as x approaches 0 from the right of f of x is 0. And the limit as x approaches 0 from the right of g of x equals 0. So notice it's no longer infinity now that I've defined these differently. So I have 0 over 0, which is an indeterminate form that I can apply L'Hopital's rule. Therefore, by L'Hopital's rule, we have the limit as x approaches 0 from the right of f prime of x over g prime of x. Now, what's f prime of x? Well, the derivative of sine x is cosine x, and the derivative of x is 1. And what's the derivative of g of x? Product rule. Well, the derivative of x is 1, so we have sine x plus the derivative of sine x is cosine x, x cosine x. So what happens as this limit goes to 0? Oops, limit as x approaches 0 from the right. So on this one, the top we have 1 minus 1, which is 0. And then on my denominator, I have 0 plus 0, which is 0 over 0, which is an indeterminate form again. So what do I have now? I need to define L'Hopital's rule again. So let k of x equals cosine x minus 1, and I'm going to let, let's say, h of x equals sine x plus x cosine x. I can already tell I'm not going to get to this one, or I'm going to go over this one, so I'm just going to cross that out. So let's save that as a warm-up. We'll do that another day. So now let's check my limits. The limit as x approaches 0 from the right of k of x equals 0. The limit as x approaches 0 from the right of h of x equals 0. So now I can say, therefore, by L'Hopital's rule, this equals the limit as x approaches 0 from the right of k prime of x over h prime of x, which for this problem, the derivative of k of x is negative sine x over the derivative of this function. Well, let's see, the derivative of sine is cosine x plus product rule. Let's see, derivative of x is 1, so that's cosine x plus x, and the derivative of cosine is negative sine x. So now what happens as, oops, I should have said the limit as x approaches 0 from the right of this approaches 0 over 1 plus 1 plus 0, which is 0. So sometimes we have to do L'Hopital's rule more than once in a problem. Excuse me. So let's practice one more in this last video.